Alright, in this video we're going to learn how to make a Schedule 80 pipe in Hypermesh, and we're eventually going to do some analysis, some heat transfer and some thermal stress analysis in in ABAQUS. So to start off with, let's just pick out a pipe. Now for this job I'm going to do a 24-inch Schedule 80. So here's the dimensions I just found on a website. Schedule 80 pipe. Here are the dimensions. The outside diameter is 24 inches with a wall thickness of 1.125 inches, and then it gives some other details down there. So I have this written down. The important thing is the outside radius will be 12 inches and the inside radius will be 12 minus 1.125, which is 10.875 inches. So I have a new blank Hypermesh screen, and I'm going to just put in a couple of nodes here. I'm just going to center this on the origin, so I'm going to put a node right in the middle. There it is. Yeah, there's more than one way to mesh this. What I'm going to do is do a cross section, and then I'm going to drag it down to represent the length of the pipe. So I'm going to go in here to geometry, and I'm going to go to lines. I'm going to select the circle, and for the circle I need a node list. There's the center of the circle. It's going to be about the z-axis, and it's going to have a radius of 12 inches. Now you may notice I'm using English Standard Units in this analysis, and part of the reason why I want to do this is it's the more natural unit for this pipe. But I want to show you how big of a pain English Standard Units are in heat transfer analysis, and we'll get to that a little bit later. So I'm going to create the OD. Well, I should make a component first, right? So I'm going to make a component, and I'm going to say OD. And I'm going to create that line. It's a circle, okay? And then I'm going to go back and create a new component, call it ID. Maybe have a nicer color than that so that we can see a little easier. And that's going to have the 10.875 inch radius, and I'm going to create that. Oop, I need to go back and select my center node. There it is. Okay, so that's the cross section of our pipe. Now I want to mesh this, and it's going to take a little bit of work to mesh this. We can't just select the outer circle and the inner circle, and let me show you why. Let's go ahead and make a new component, and we'll try it, and we'll see what works and what doesn't. So we're going to go to 2D, and let's try our ruled mesh again, or maybe select this inner line and this outer line. We're going to mesh without a surface, and let's see what happens. Well, it might let us do it. So here we have a very, very coarse mesh, and maybe we want to set the edges to 36 would be every 10 degrees. Let's try 72. Let's try to mesh that. Now it's got hidden lines on. Okay, so that's way too fine. It put 72 elements through the thickness, which is not what we want. So let's back that up. We're going to reject, and we're going to specify some different numbers here. Let's see. Let's set this edge to a different number. Okay, so what I did was I set all of them to 10, and this is the number of elements through the thickness. Maybe we want to set that edge to 4. And we want to set the other edges to 72. And let's mesh this and let's see what it looks like. Okay, so that looks like a nice mesh. If we use 20 noded elements, we could probably get some pretty good through thickness stress distributions. I want to be a little bit careful when I make these meshes because I know a lot of you are going to be using the student edition of ABAQUS, and you don't necessarily have the ability to deal with huge meshes, so I don't want to make it too fine. Alright, so that looks good for now. Okay. I'm going to make a new component called pipe. Let's give it a nice color, maybe something that we can see easily. Maybe this light blue. And I'm going to drag those elements down the z-axis. Let's not make it too long. Let's just make it 3 feet. It's going to be kind of a squat looking pipe, but let's just make it 3 feet. Now we're using inches, so that's going to be 36 inches. And on that, let's make about 18 elements. Let's see what that looks like. So we're going to drag it down the plus z-axis. We have the z-axis selected, and let's just hit drag plus. Let's spin this around in 3D. Let's fit it, and let's do a solid shading. Okay, so that doesn't look too bad. The elements are a little bit skinny, but the edges, the angles are not very distorted. They're not distorted whatsoever, so that looks pretty good. Now when I save this mesh, I'm going to do what we did before. We're going to turn off everything that we don't need. I'm going to get rid of that temp node, otherwise it'll put that temp node in there. And I'm going to export a solver deck, and let's call this pipe 1 with, I'm going to call this a coarse mesh. Going to output only thing that's displayed, and I'm going to hit export. Okay, so let's save that to my desktop. Let's go back to the model, and I want to do this over again. I'm going to create a new component. I call this pipe 2. And let's create our 2D elements. Well, actually I should call this X section 2. Maybe I'll make that a little bit different color. Okay, we're going to do the same thing. We're going to do a ruled mesh. We're going to select the inner line and the outer line. And we're going to set all of them to maybe to 10. And maybe particular, let's do 72. Let's select these edges. And let's see, if we do 144, maybe we'll have an increased mesh density. Okay, that's going to be really fine mesh. And I think that's okay for us. So now this is a very fine mesh. We have 10 elements through the thickness. We have 144 elements around the circumference. So we're going to return, and we're going to make pipe 2 the current, and we're going to do a 3D drag. I'm going to drag elements that are displayed down the z-axis 36 inches and instead of having 18, let's do 36 elements down. Now again, if you're using the student edition of ABAQUS, you may not have the ability to analyze all of these, but I want to show you some things later. So let's drag down that axis, make this maybe a different color, something we can see, kind of a purple maybe. And if I spin this in 3D, there it is. I'm going to turn off the geometry, and I should really check to make sure I don't have any duplicate nodes, or I don't have any cracks in here. I don't think I do, but let's go into the tools and let's check our edges. And in fact, it looks like we might have a duplicate here. Let's preview the equivalents, and if you see here, I do have this seam where I have duplicate nodes. So I'm going to equivalence this, get rid of that seam, and now I'm going to export this file as a solver deck, and I'm going to change this to fine mesh. I'm going to export what's displayed. It'll write out those nodes and elements. That also means I need to go back here to my original pipe, and I need to check my edges for this one. And I have duplicate nodes in there. So I'm going to have to equivalence those and then re-export that mesh as a solver deck. And I said this was pipe 1. Coarse mesh. And I'm going to say yes to overwrite that. Okay. So again, it's always a good idea to make sure you check for duplicate nodes before you export any of your mesh. You need to do that equivalencing. Alright, so what we'll do is we'll bring those into ABAQUS. We're going to do some heat transfer analysis, and one of the things I want to do eventually with this is I want to show you how you can do an interpolation scheme if you have mismatched nodes from one mesh to another. Like maybe you did your heat transfer analysis with a very fine mesh, and you want to extrapolate or interpolate the nodal temperatures to a coarser mesh. I will show you how you can do that. But for now, this is good, and we'll pick this up at a later time with ABAQUS.